Alright, in this lesson, we're going to talk about how to solve linear equations. And first of all, we need to understand that a linear equation is different than the expressions we've been dealing with so far. So far, we've had problems like 2x plus 7, and now we're going to have something like that, but then we're going to say, oh, it's equal to 5. In other words, the big difference is now we're going to have an equal sign. Okay? Before, expressions did not have an equal sign, it just had something like this, and perhaps it had a number out in front like a 3 that I was supposed to actually distribute and simplify. Well, now again, we have equal signs, and we actually need to find a final solution, a answer for x, that if I plugged that answer in for x, whatever that number is, it would make a true statement. So we're trying to go through a process to figure out what makes x. What would I plug in for x to make this a true statement? And then what you have is you'll have different answers. For example, see this little bracket symbol? This is what you'll see in the lab. It'll actually look like this. It'll put brackets, and then you'll have a box to put your answer, and then it'll close the brackets for you. What you're supposed to do is whatever the answer is, say the answer was 5, that made this statement true up top. Well, that means that x equals 5. So that's your solution set. So what you do is you tell the lab 5 is your set. Okay. Now don't put an extra set of brackets inside there, because it doesn't like that. It'll tell you your answer is wrong. You just put whatever the answer is for the 5, put it inside your brackets. Now you also have possibilities, and there will be an option for all real numbers to be your answer, and there will be an option for no solution, or the null set. We'll come into some examples in a moment that'll show you when to use those features. Now you'll see some problems that ask you if an equation, or if a couple of equations are equivalent expressions or equivalent equations. So let's take a look at a problem. So these are two equations, and the question is are these equivalent equations? Well, in order to have equivalent equations, what we're really asking is, do they have the same solution set? In other words, they both have the same answer for x. Well, the answer for both of these is that x equals 3. If I put 3 in here, that would cause me to get 15 plus 2, which is 17. If I put 3 in over here, I get 5 times 3, which is 15. So both equations check off in that they both have the same solution set. So that means these are equivalent equations. So let's have an example where something is not an equivalent equation. Okay, for this first equation, we've got 2x equals 10. What that means is that x is actually equal to 5. If I put 5 in here, 2 times 5 is 10. Well, if I put 5 in over here, 3 times 5 is 15. 15 does not equal 20. So what that means is these are not equivalent equations. Okay, so that'll help you solve a couple problems in your homework. Now we're going to go through the process of solving our first linear equation. In order to do that, we need to go through a few steps that I'll write off to the right-hand side. Alright, the notes I've got on the right here, I use shorthand to kind of work through it and fit the space. CLT, that means combine like terms, and then you want to do that on the left hand and the right hand side of the equal sign. Okay, so that's the first thing we're going to do here. And then we're going to move the like terms that remain to be on the same side of the equal sign. And then finally we're going to do the opposite of the number in front of the variable to actually solve. Now we got to start by combining our like terms. So we got to identify my like terms on the left hand side, which is going to be my 4x and my negative 2x. Now negative 5 is not like terms with it, so we're going to leave it alone. So I'm going to draw an equal line. It's just a dotted line to keep my equal line in the same place, and I'm going to combine the like terms that I have. So I got 4x and negative 2x. That's going to give me positive 2x, and I bring down my negative 5. My equal sign comes down. And then I take a look at my 4 and my 3. Those are like terms, so I combine them to get 7, and then I say plus 6x. Now, we're at step 2. We're supposed to move like terms that remain. Now, what is best to do is to move your smallest variable first, which for us is the 2x. So I went ahead and wrote that here. We move our smallest variable first. Now, we're going to want to move this 2x to be on the other side, and then we'll eventually want to move the 7 to be on the left-hand side. Now, we move things by doing a process of opposites. Now, opposites mean I have a positive 2x here, so to move it, I do the opposite of having a positive 2x, which is a negative 2x. And I do that to both sides. If you do it to one side, you do it to the other, you're good to go in algebra. Okay, so now positive 2x and negative 2x cancel. So then I'm just left with, on the right hand side, 6x minus 2x, which is 4x. Okay, so I go ahead and bring down my 7, and I bring down my negative 5. Okay, so now the next step is to get rid of the 7, because its like term is the 5, so I need to get over by its buddy. So I do the opposite of a positive 7, which is a negative 7. And then I go ahead and simplify. The 7's canceled, so I'm left with 4x equals negative 5, and negative 7 gives me negative 12. So now I have to do my very last step, which is do the opposite of the number in front of the variable. So I'm stuck with the number right here, the 4. Okay? So the 4 is multiplying to the x, so I need to do the opposite of multiplying by 4, which is dividing by 4. So I've got, let me write it here, negative 12 equals 4x. So the opposite of timesing by 4 is to divide by 4. So if I divide both sides by 4, I'll get x equals negative 12 divided by 4 is negative 3. That's the answer for this problem. Okay? So what that means is if I took negative 3 and plugged it in for x here and here, it would give me the same answer as if I plugged in the negative 3 right there. The left side will equal the right hand side. Okay, so let's try another problem. So you can see in this problem I'm supposed to solve again. So we're going to simplify the left hand side and the right hand side just like these notes before said. Combine like terms in left and right. So before I do that, I actually need to distribute a little bit. And I've got 2x minus 10 plus 3x. And I got my equal line. I'll just go ahead and dot that there. Equals x plus 6. And now I'm ready to actually combine my like terms, so I had to simplify a little bit first. And my 2x can go with my 3x. Okay. Now notice I'm not worried about the x on the other side yet because it's not on the left side. I can only deal with one side at a time. So my 2x and my 3x should combine to give me 5x's. I bring down my minus 10 equals x plus 6. Okay. Now there's no more simplifying on the left or right to do, so now I need to move my smallest variable, which is the x. I do that by subtracting it, because the opposite of having a positive x is a negative x. Okay? And then that's going to cause my x's to cancel, and I'll be left with 4x's. Now for the sake of space, I'm going to go ahead and move my 10 at this place also. So the opposite of a negative 10 is to do a positive 10 to both sides. And that causes the 10 to cancel, and I'm left with the right hand side equals 16. So now I've got 4x equals 16. Well, just like the last problem, to get rid of a 4 that's being times by the x, the opposite of that is to divide by 4. And my final answer will be x equals 16 divided by 4, which is 4. So 4 is a number that if I plug it into the left side and to the right side, it'll give me the same answer. And in this case, the answer on the left and the right will be 10. Now just to show how that works, let's actually plug it in here. If I had the 4, I plug it in for x minus 5 times the 2 out in front plus 3 times the 4. And that's supposed to equal 4 plus 6. Now, if I take my 4 minus my 5, I'll get negative 1 times my 2 will give me negative 2. Plus 3 times 4 is 12. On the right hand side, 4 plus 6 equals 10. So you can see the left hand side is going to be equal to 10 also, and 10 equals 10. So you can see that my solution checks out and I'm good to go. Now we're going to do one that looks more complicated at the beginning, and it is, but it's still just a process of simplifying first. Now notice there's brackets here, and then on the inside there's parentheses. Whenever you have brackets or multiple sets of parentheses, you want to start off with the inmost parentheses first and see what you can do there. Well, there's nothing to do with the 3 minus x, but in front of it, you can see that there's a negative sign. It can get distributed, and then I'll be left with 2x minus 3 plus x, it needs to change the sign, plus 5. Now that's still inside the brackets. Okay, so we can go ahead and further simplify that. Notice I'm just kind of ignoring the right hand side for now because I'm not doing anything with it. And I combine my like terms. The 2x goes with the x to give me 3x's. the negative 3 goes with the 5 to give me 2. And that's, again, still inside the brackets. You can change them to parentheses at this level. They don't have to be brackets anymore, but we'll leave it like that. And then, to finish, I need to take my 4 and distribute it inside those brackets. And when I do that, I don't need the brackets anymore. 4 times 3 will give me 12x, plus 4 times 2 is 8. Now let's take a look at the right-hand side. The right-hand side only needs a negative sign to get distributed. And now I'm at negative 2 minus 7x. So now I'm basically where the other problems were, but I had a little bit more work to get there. So now it's just a couple steps and I'm going to have the victory of solving for my x. For the sake of space, I went ahead and erased and moved it up. Now I'm going to move the smallest variable next. The smaller variable is negative 2x. The opposite of negative 2x is having a positive 2x added to both sides. And that is going to cause my 2x's on the right to cancel. And on the left-hand side, I get 14x. Now I'm going to go ahead and get rid of my 8 here by subtracting it to move it to the other side. I'm sorry, I put 2x and I meant to just put 2. Let's back up a little bit. So let's try that again. We should have had the 7x move. The opposite of 7x is adding 7x to the other side. And then those cancel, and I'm left with negative 2 on the right-hand side equals 8. And then I take my 7 and my 12, and I go ahead and get 19x. And now I need to move my 8, so I subtract it from both sides. And that's going to give me 19x on the left-hand side equals negative 10. And then I'm going to move this over here so that I have room to show the last step. 19x equals negative 10. And so all I have to do is do the opposite of timesing by 19, which is to divide by 19. And x is going to equal negative 10 over 19. Now, I know that's a really ugly answer, but it is the correct answer, and it's the answer that would work in the lab. You don't have to simplify or give the decimal. Okay? So sometimes it does give you a weird fraction, but this process is very similar to the previous ones. It's just a little bit more work in simplifying the left and the right before you start moving variables. So now we're going to take a look at solving some decimal problems. Or not. Because who wants to solve a decimal problem if you don't have to? All the decimal problems that you're going to have in this section, you can actually get rid of the decimals by multiplying the whole equation by a power of 10. In other words, just move the decimal. If I move the decimal over 2 places here, and then I do it once for each group, in other words, I do it for the 9, but I don't do it for the 15. So I do it for the 9, and then I do it for the 0.07, but not for the 15. So again, once for each number group. So if I circled that guy, this guy, and that guy, you see that I only move the decimal for one number in that group. Okay, so if you move the decimal for twice in each one of those numbers, you can actually rewrite this equation to be 6 plus 9 times 15 minus x equals 7 times 15. And this problem is much nicer now, and it's not quite as ugly because we don't like decimals as much. So now we just go ahead and simplify like we were doing previously. We just distribute our 9, and that should give us 135 minus 9x. And then I bring down my 6 equals 7 times 15. That should give me 105. And now I just go ahead and combine my like terms and move them away from the variable. So I add my 6 and my 135. I should get 141 minus 9x equals 105. And now I go ahead and move my 141 to the other side by subtracting it. And that's going to give me negative 9x equals negative 36. Okay, so now let's write that off to the side because I ran out of room. Negative 9x equals negative 36. To do the opposite of timesing by negative 9, I need to divide by negative 9. And please don't just divide by 9, you got to bring the negative also. So dividing by negative 9 on both sides, the 9's will cancel, and the negative signs cancel, and I'm left with x equals negative 36 divided by negative 9. The negative signs cancel, so it'll be positive 36 divided by 9 is 4. So x equals 4 is your final solution. So even though the problem looked really bad with the decimals at the beginning, it turns out to be not so bad in the end. Now we're going to take a look at our fraction problems. We're going to bust up these fractions by getting rid of the actual denominator, so it isn't a fraction anymore. Now notice this is a negative fraction, okay? But there's an 8 on the bottom. Well, I want to get rid of that 8, okay? I get rid of the 8 by doing the opposite of dividing by 8. And the opposite of dividing by 8 is multiplying by 8. If I multiply by 8 to the left side and to the right side, the 8's cancel. And now I'm left with negative 7x equals 6 times 8, 48. And then all I have to do now is just divide by 7, negative 7, and I'll have my answer. X equals negative 48 over 7. Now you could get a mixed number or decimal, but this is just fine. So that's one way to do these problems. There's one more way that you can do this. I can get rid of the fraction in one whole step by flipping multiplying. I say flipping multiplying by 8 over 7 and a negative 8 over 7. That causes the whole fraction to go at one step if I multiply this side by negative 8 over 7 as well. And so now the whole fraction's gone, and I'm just left with x equals, and then I multiply this out to get my negative 48 over 7. So you get the same answer, it's just one step versus two. Okay. So now the bust-em thing comes more in line with this, where I want to multiply by the denominator like I did in the last problem first. Last one was an 8. This one I've got 6 and 3. What I want to look at what is the common denominator. Okay. So you see your equal signs going on here. All I have to do is multiply everything by the least common denominator, and I won't have any fractions. I won't have any fraction problems. So now, the least common denominator, with 3 and 6, is just 6. So if I multiply everything by 6, and by everything I mean each number group, by 6, the denominators cancel. So these ones, the 6's cancel. 6's cancel over here. So all I'm left with on the right-hand side is x plus 5 plus x minus 3. No fractions. On the left-hand side, I reduce with a 3 and make this a 2. So now this 2 needs to be multiplied by the top, the leftover part. So it turns into 2 times 4x plus 1. Okay. So what I'm doing is I'm multiplying each number by 6. In other words, I'm multiplying the left side of the equation and the right-hand side of the equation by 6. And if you do it to one side, you do the other, you can do it. So that's how I get rid of my denominators. So now I just need to simplify what's left over as my other problems have been. So I just distribute my 2, and that gives me 8x plus 2 equals, now you take your x and your other x, combine those, and that gives you 2 x's, and then you have 5 minus 3, which gives you 2 plus 2. So now I move my 2x, I subtract it, and then I'm going to subtract my 2 here to be on the other side. And now something different is going to happen this time that we haven't seen in a while, is that my 2's are going to cancel to be 0 equals, on the left hand side we're going to get 6x. And so you have 6x equals 0. So you want to get rid of that 6 by dividing by 6, and you get x equals 0 divided by 6 is 0. So the thing that makes this equation true is 0.